A set of data structures, related classes, and interfaces is called as collections framework. A set of collection classes and interfaces is called as collections framework. A set of data structures, related classes, and interfaces is called as collections framework. So this is also, both are same. For understanding purpose, this one I given. So actually, according to Sun Microsystem, first one, a set of collection classes and interfaces is called as collections framework. Here, a set of data structures, related classes, and interfaces is called as collections framework. To understand first definition, what is collection required? To understand second definition, what is data structures required? Okay. Now, collection. Noted. A collection is an object. A collection is an object that represents group of objects. A collection is an object that represents group of objects. A collection is an object that represents group of objects. Objects we can group together as a one more object. That is called collection. A collection is an object that represents group of objects. So here, objects we can group together as a one more object. Objects we can group together as a one more object. That is called collection. And here, the type of classes and interfaces grouped together, that is called collections framework. Say, object contains data. Already know. Object reference contains hash code. Object contains data. Object reference contains hash code. In a one object, n number of variables possible. Instance variables. The type of objects you can group together as a one more object. That is collection. That type of classes and interfaces you can group together. That is called collections framework. Okay. Here, data structures. Data structures nothing but arranging data in different formats. Note. Data structures. Arranging data in different formats. Arranging data in different formats is called as data structures. Arranging data in different formats is called as data structures. Arranging data in different formats is called as data structures. See, data, different formats we can arrange. That is data structure. Like example, stack, queue, tree, graph, these are data structures. Like in academics, I think all BTech students studied. Even other groups also. CN data structure is common for all students, no? That is. But the data structures, it is one concept. Data structures is one concept. You can implement in C language also, C++ also, Java also. In other languages also. Data structures, we can implement in any language. So it is a concept you can implement in any language. Now, here, arranging data in different formats is called as data structures. Data structures purpose, some classes and interfaces are there. Those all group put together. That is collections framework. So, for example, arrays. What is array? Collection of similar data elements. Array is also one collection. Array is also one collection. Hundreds of elements will group together as a one object. Array is also collection. Okay. Now, array is a collection of similar data elements. Already know. Here, arranging data in different formats is called as data structures. Here, you observe. Suppose, if you write like this, how many objects created? How many objects? One object created. If I write like this, how many objects created? How many objects? One object only created. Okay. That is array size. Array object created. Employee object not created. Employee object, if you want to create, new constructor required. Is it constructor? No. Array object created. After this, for loop, integer I equal to 0, I less than e dot length, I plus plus. In this, e of I equal to new employee. Then 100 objects created. Okay. Now, one array object created, 100 employee objects created. Like that. See, actually what will happen? Like this created. 0, 1, 2, 3 like that. Last one 99. It is index. 0, 1, 99. It is an object. It's an array object. Employee array object. This object referred by E. Like this. Okay. Now, in first line, like this created. All will be null, null, null will be there. Okay. Now, after this, what will happen? I value 0, 0 less than 100 true. Then E of 0 equal to new employee. Then employee object created. That object hash code stored here. Again, E1, 1 less than 100 true. E of 1. E of 1. E of 1 object created. That is stored here. Like this. E of 99. That object stored here. Now, these all employee objects. Okay. Now, this is array object. These are employee objects. If I print E, what E contains? Hash code. If I print E of 0, hash code only. E of 1, hash code only. Because here also hash code only. Here employee object hash code. Here array object hash code. These all hash code only. Here data will be there. Okay. Suppose accepting 100 employees information, displaying 100 employees information, while displaying employee names in alphabetical order, I want to display. It is not a small thing. Data will be in object format. Okay. Accepting 100 employees, displaying 100 employees based on employee name in alphabetical order. It is not a small task. It is a very big task. But these all we can implement in with using collections. Very simple. Using collections. That purpose collections. These are very difficult to write programs like this. That's what collection framework introduced. Okay. So in real time, huge amount of data is there in real time servers. To manage the data, it is not easy. It is very difficult to manage the data. In Gmail server, how much data is there? In WhatsApp server, how much data is there? Amazon website, how many items are there? How much data is there? Like that. Those all, if you want to maintain properly, data processing frameworks required. For that, this knowledge required. These all. But everything, if you want to write like a C language, it is not so easy, very complicated. That is the reason, these all. Now, just you see, writing, just creating 100 objects only not easy. Again, accepting, displaying, alphabetical order, sorting, these all not so easy. But by using collections framework, very easy. Programmer, no need to put efforts. Logics already written. Use that logics. That's it. That is collections topic. Okay. Now, it is also in collection. But it is not so easy. Very difficult appears. Now, it is only diagram I given. But accepting, writing, displaying, these are not so easy. But with collections framework, very simple. Okay. Now, if you write like this, what will happen? One object created. That is array object. If you write like this, 100 objects created. Every object has code stored here in array. Okay. Like this, it is going to be stored. But that type of collection class and interfaces already group put together in a collections framework. Okay. Now, collections framework concept, you observe. See, advantages of collections framework. Advantages of collections framework. No? Advantages of collections framework. Advantages of collections framework. See one small example. Suppose in a Facebook, for example, Facebook. This is your name. Okay, this is your name. Here, your friends list. Okay, your friends list. This person having these many friends. Okay. Is there any limitation to add friends? No. Some celebrities, politicians are having lakhs of friends. You know. Okay. Like this. Again, this person friends also will be there. No? This person friends. Again, this person friends. Okay. Again, this person friends. Like this. Again, this person may be friend here. This person may be friend here. This person may be friend here. This person may be here. This person may be here. This person may be here. Like that will be there. How it will be there, you observe? Now, like this, I want to maintain the data. This is my task. Is it easy to write? Very difficult task, no? So, that person may be friend here or that person may be friend here. Relations, how it is, you observe? Okay. So, how they are writing coding, you observe? It is very complicated logics we have to write. But if you use collections, no need to put efforts that much. program already written, use library. So the relations very difficult to manage, data. In a real time, very difficult to manage the data. Okay. Further, so many softwares introduced, but those softwares also written with programs only. Those programs you are using with programming language. If it is C language, you need to write everything. But Java very simple as compared to C. But as compared to Java, tools are very easy. But how tool is designed with Java? How this Java library designed with C language? Like that will be there. Okay. Day by day, what they are doing? They are reducing burden to programmer. Day by day, why new technologies are coming? To reduce the burden to programmer. That's it. Okay. So, first advantage, reduces programming effort. First advantage, reduces programming effort. Advantages of collections framework. Advantages of collections framework. See, advantages of collections framework. Reduces programming effort. Programmer no need to put efforts. Sorting logic already developed. Searching for one element already developed. Hashing logic already developed. Everything already available. See, data structures like a linear list, linked list, stack, queue, tree, graph, sorting, searching, hashing. So many concepts are there. Those all predefined in Java. That is only collections framework topic. But if you want to write data structure program yourself, it will take so many lines and as well as it will take more time to learn. Only data structures, if you want to learn, minimum 3-4 months required. Okay. But that is just one topic in Java. You observe. Data structures in C. Data structures in C++. Data structures in Java also separate course is there. But here, predefined data structures you are using in Java. That is one topic here. Okay. Reduces programming effort. Programmer no need to put efforts. Logics already present in Java library. The library you have to utilize. That is first benefit. Programmer no need to put efforts. Second benefit. Increases programming speed and quality. First benefit, reduces programming effort. Second benefit, increases programming speed and quality. Reduces programming effort. Second one, increases programming speed and quality. Reduces programming effort. Okay. See, just now one array given, employees array, not integer array, character array, float array. Integer array simple, but employee array, it is not so easy. Accepting 100 employees information, displaying 100 employees information, not easy. And even if you write system dot, see in that example, system dot out dot println e, if I write, it will print hash code. If I print e of I, also hash code. If I print e of dot employee number, again plus slash t plus e of I dot name plus slash t plus E of I dot salary. Let's if you write in a for loop, if you write, then data printed. But in collections, this data just you pass in collection. System dot out dot println collection reference you pass. ToString method also prepared. Only if you write system dot out dot println E, 100 implies data printed. Logic already written. That is programming speed increased, quality improved. For loop also not required for printing array elements. For printing array elements also, ToString method is there. Then it will print. Then no need to write logic. So then what will happen? Speed increased, quality improved. That is also benefit. Third one. Allows interoperability among unrelated APIs. 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 Advantages of collections framework. Reduces programming effort, increases programming speed and quality, allows interoperability among unrelated APIs. See, program interoperability. So actually, with collections API, independently you can write program. Possible. Collections API and suppose in advanced Java, JDBC is their separate topic. Separate API for JDBC, separate API for Solids, separate API for JSP. Like that will be there. Then collections we can use with JDBC also. Collection we can use with Solids also. Collections can be used with JSP also. Even other technologies also. Hadoop, big data, and Android, there also we can use. There also collections we can use. In Selenium, other places also we can use. That API, this API not related, but we can use. So it is allows interoperability among unrelated APIs. Solids API different, collections API different, but can be mixed. You can. That is interoperability. Anywhere you can use. So if large amount of data, huge amount of data is there, if you want to maintain, then we require this topic. Huge amount of data. For example, Gmail. How many Gmail users are there? Crores are there. Okay. Some operations if you want to perform. Today, how many people registered? I want to know. How many people from 3 months they didn't open mailbox. I want some task like that. Like different application. Example, Amazon application. How many people purchased one particular mobile today? In India, in US, worldwide, ratings required. Like to improve their business. That data required. That data. How will get it? You can retrieve from database, you can hold in collection, you can perform operation. That is, we can print with tools in a graphical representation. That type of tools also are there. Data permanently stored in database. We can retrieve the data. But the data, if you want to store in a temporarily in RAM collections, with this data, some tools are there. With tools, graphical representation possible. Then we can display that each mobile percentages, market share. How many people purchased in India, how many people purchased in US, how many people purchased worldwide rating and India rating, that particular state rating, only district rating, everything you can find out. At that time, huge amount of data will be there. At that time, these collections are required. Data processing frameworks also designed with this collections API. Okay. Now, here, what we will do, how to use collections, you are going to learn. Next, read it. All collection classes and interfaces are the part of java.util package. All collection classes and interfaces. All collection classes and interfaces are the part of java.util package. All collection classes and interfaces are the part of java.util package. See, one small example you observe. Here, just in type, I'll type in Google smartphone market share in India 2023. I'll type it. Just if you click on images, see here, ratings are there. No? For example, this is, you observe, this is graphical representation is there. You observe, Q1 2023. Q1 2023, nothing but January, February, March. April, May, June. June not completed. That data maybe next month or after one more month it comes. See, Q1 2023 market share here. Here 22%, 21%, 11%, 10%, 7%, 29%. What is here? Colors, blue color, black color, orange, here information there. Blue color, Samsung, black color, Apple, orange color, MI. This is Oppo, Vivo, others. You observe here 22% Samsung leading. Next, here Apple. Next, MI, Oppo, Vivo, these all others. See, to all other companies, just 29% is there. Remaining all these all leading. So, here it is market share in India. Okay, this is global smartphone market share. Okay, like this will be there. See, this is only global worldwide. This is a worldwide rating came. India also separate will be there. Like this, market shares will be there. See, this is India, I think. Right, India market share. You observe this diagram, you observe here Apple not there. You observe iPhone not there, no? Samsung, Vivo, MI, Oppo, Realme, others. See, in India rating, how you see how it is, and the worldwide rating how it is. In India, top position, Samsung. Okay. Next position, Vivo. Next position, MI. Here, you observe Samsung, Vivo, MI, Oppo, Realme, others. But in worldwide market sharing, Realme doesn't appear, no? Not appeared. Okay. So, here market share, their market share, you observe, somewhat different will be there. This data, how it is possible? Like in a graphical representation, the backside, how much data will be there? You observe. To bring this graphical representation, how much data is there worldwide? Worldwide data, India data. They'll take no. So, whenever you purchase one mobile from any place, okay, that information stored in database. That information stored in database. Anywhere you purchase mobile, that information stored in database. From particular location, how many people purchased it, that information they'll retrieve. Where it will holds collections. On that, how they'll process data processing frameworks. There's some logic. How this graphical representation, just if you provide this data for data analysis tools, it will print, it will display these graphics. Power BI, Tableau, these technologies are there, no? ClickSense, Power BI. That is also there. One line code also no need to write. Just bring the data, provide there, automatically graph generated. Those are tools. But how they written? With programming language. Code already written. Like this, in real time, huge amount of data will be there. At that time, these collections will help you. So, once if you enter into software company, then you will understand how much importance is there for collections. Okay? Because huge amount of data is there, then required. Huge amount of data, when it will be there, in real time only will be there. Codes of records will be there. Okay? So, programmer no need to put efforts. Reduces programming effort. Programming speed increased. Quality improved. Anywhere you can use. Every project they are using collections. Compulsory. That's what. This topic is most important for interviews. You attend any interview, definitely they'll ask questions from collections. They'll ask minimum 4 or 5 questions comes from collection. If you give answers, they may continue next topic. If you don't give answer, that day total interview collections only. Okay. If you don't give answer. In a collections, if you don't give answer, then what interviewer will do? All questions in collections only ask. It will happen. Okay. That's what this topic is most important. Okay. Now, all collection classes and interfaces are the part of java.util package. Java is a main package. Util is a sub package. Util, utility, language. Language related classes and interfaces, they placed it in lang. Utility classes and interfaces placed it in util. Like that. IO, input output related class and interface, IO. You studied. Net, network programming related net package. Okay. Now, all classes and interface of collections classes, util package. Next, java.util package classes and interfaces are divided into 2 categories. Java.collection classes, Java.util package classes and interface are divided into 2 categories. Java.util package classes and interfaces are divided into 2 categories. First one, Java.util package class and interface are divided into 2 categories. First one, collections framework collections. Second one, legacy collections. Collections framework collections, legacy collections. Java.util package classes and interfaces are divided into 2 categories. First one, collections framework collections. Second one, legacy collections. First one, collections framework collections. Second one, legacy collections. First one. Collections framework collections. JDK 1.2 and above versions. JDK 1.2 and above versions. Collection classes and interfaces. JDK 1.2 and above versions. Collection classes and interfaces are called collections framework collections. JDK 1.2 and above versions. Collection classes and interfaces are called collections framework collections. JDK 1.2 and above versions, collection classes and interfaces are called collections framework collections. So actually starting version 1.0 version also util package was there. But 1.2 onwards, they given more importance for this topic. They improved so many classes in 1.2 version. Then they changed name collections framework. Okay. But this word introduced in 1.2 version. That is the reason collection framework collections nothing but 1.2 and above versions. Legacy collections nothing but old version. Next, read it. Legacy collections. JDK 1.0 and 1.1 versions, collection classes and interfaces are called legacy collections. JDK 1.0 and 1.1 versions, collection classes and interfaces are called legacy collections. JDK 1.0 and 1.1 versions, collection classes and interfaces are called legacy collections. See, collections framework collections 1.2 and above. So actually framework word introduced in 1.2 collections framework. After advanced Java frameworks are there, Struts, Spring, those all. That is different. This is different. Don't compare with that one. Okay. Don't compare with that one. That framework is different. This framework is different. Here also maximum code already written. That's what they given like a framework word. But that is ready-made programs. It is just a ready-made library. That's it. That is ready-made programs are there. Okay. That is framework. That framework is different. Spring framework, Spring Boot framework, Hibernate, Struts, those are different. Okay. Here, writing program purpose, collection data structure related program purpose, some libraries are prepared. Those all available in util package. Okay. Util package class and interfaces divided into two categories. Collection framework collection, legacy collection. Old version 1.0, 1.1 legacy. New version 1.2 onwards collections framework. So starting two versions 1.0, 1.1. These two versions only legacy. 1.2 onwards collection framework collections. Okay. Next. Collections framework collections are divided into the following subcategories. Collections framework collections are divided into the following subcategories. Collections framework collections are divided into the following subcategories. First one. See, collections framework collections are divided into the following subcategories. First subcategory, core collection interfaces. Second one, general purpose implementations. Third one, more utility collections. First one, core collection interfaces. Second one, general purpose implementations. Third one, more utility collections. Collections framework collections are divided into the following subcategories. First one, core collection interfaces. Second one, general purpose implementations. Third one, more utility collections. See, Java.util package class and interfaces, two categories divided. First category, again, three subcategories divided. Today, first category will learn. First one, core collection interfaces. These interfaces are the foundation of collections framework. 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 Say, core collection interfaces. These interfaces are the foundation of collections framework. Core, basic, like core Java, like that core here also, basic. But interfaces, these interfaces are the foundation of collection framework. Here, interface, what is interface? Collection of public static final variables and public abstract methods. Here, only abstract methods are there, but all implemented here. No need to implement by us. Implemented. Now, with this interfaces theory part only theory. We are not going to implement theory. With this theory, this program you'll understand. And that more operations you can perform. Third one. These are old legacy. Okay. Now, list of core collection interfaces. List of core collection interfaces. First one, collection. Second one, list. Third one, set. Fourth one, map. Fifth one, sorted map, sorted set. Sixth one, sorted map. Seventh one, navigable set. Ninth one, queue. 10th one, deck. List of core collection interfaces. list of core collection interfaces. Collection, list, set, map, sorted map, navigable set, navigable map, queue, deck. These are interfaces. Each word first letter capital. Sorted set, S capital, S capital. Sorted map, S capital, M capital. Write clearly. List of core collection interfaces. Collection, list, set, map, sorted map, navigable set, navigable map, queue, deck. These interfaces, no need to implement by us. Already implemented. Okay. Now, first one. Collection interface. It is a root interface in a collection, one-dimensional collections hierarchy. It is a root interface in a one-dimensional collections hierarchy. Collection interface. It is a root interface in a one-dimensional collections hierarchy. It is a root interface in a one-dimensional collections hierarchy. It is a root interface in a one-dimensional collections hierarchy. You studied which is a which is a class implicitly inherited in every Java class? Object class. That is super class for all classes. You take any class in Java, that is super class. At the top of the hierarchy, object class is there. Like that, in a one-dimensional collections, top of the hierarchy, this interface will be there. So, which are common to all one-dimensional collections, those methods are present in this interface. Okay. Next. List interface. It extends collection interface and it maintains sequences. 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 Set interface. It extends collection interface and it maintains sets. Here, 1 minute. Here, one more point is there. It allows duplicate elements. It does not allow duplicate elements. List interface. It extends collection interface and it maintains sequences. It allows duplicate elements. Sets. Set interface. It extends collection interface and it maintains sets. It does not allow duplicate elements. Now I'll explain. I'll explain with a diagram. Note down. List versus set. List versus set. List versus set. See, it is a say it is a one-dimensional collection interface. It is also one-dimensional collection interface. It extends collection interface. So it is derived from collection. It extends collection interface. It extends collection interface. It extends collection interface. It maintains, I'll explain, just write it. It maintains sequences. It maintains sets. It maintains sequences. It maintains sets. It allows duplicate elements. It does not allow duplicate elements. List versus set. It is a one-dimensional collection interface. It is a one-dimensional collection interface. Both are one-dimensional. Both are derived from collection. It maintains sequences. It maintains sets. It allows duplicate. It does not allow duplicate. I'll explain. Index 0, 1, 2, 3, 4. Zero, 1, 2, 3, 4. See, here it allows duplicate element. It does not allow duplicate elements. Here 5 elements memory, here 5 elements memory given. See, it is a one-dimensional collection interface. This is one-dimensional. So two-dimensional means like this will be there. Like this will be there. It is two-dimensional. Rows, columns, types. Okay. It is one-dimensional. It is a one-dimensional. It is also one-dimensional. This interface derived from collection interface. This interface derived from collection interface. It maintains sequences. Suppose you will insert one element here. Next you will insert here. Next you will insert, suppose directly here. Then error comes. Sequence missed. Okay. So it maintains sequences. Sequences it maintains. Sets nothing but which does not allow duplicate. Here duplicate not allowed. Here duplicate allowed. Suppose here one element. Here one element. Here one element. Here one element. Here same element may be present, but here not allowed. Here one element. Here one element. Here duplicate not allowed. Okay. Now it is called index. It is called element. It is called index. It is called element. Okay. Now both appears like a same, no? Both appears like a same. In a programming, you will get the difference. Here, by mistake, if you write duplicate, error will not come, automatically rejected. Logic already written. Here, duplicate allowed. N number of duplicates allowed. Here, duplicates are not allowed. Depends upon our application requirement, we have to select. Suppose I want to maintain Gmail usernames, only usernames. List required or set required? Set required. Gmail username duplicate will not be there. So set required. Suppose only passwords I want to maintain. List or set? List. Passwords, your password, other people password may be same. Okay. See, for example, ATM card number. List. I want to maintain ATM cards numbers. List or set? That number is unique. PIN number. PIN number. How many digits will be there? 4 digits. Same PIN number, thousands of people will be there. Okay. Same PIN number, thousands of people will be there. Okay. But ATM card number, unique. PIN number, duplicates. But with only PIN number, it will not check. Card number, PIN number, both well validated. That's what, not a problem. So, like that, when actually data will be in a database only. Database, suppose, you'll write int A equal to 5. Int B equal to 10, int C equal to A plus B will write. This operation done in hard disk or RAM? RAM. All operations are done in RAM only. The data permanently, if you want to store, hard disk required. Okay. Later what will happen in real time? Data will be in a database, that is in a hard disk. On the data, if you want to perform operations, how will perform? First, you have to bring the data from database. That data you have to store in RAM. If you want to store in RAM, what we use? Integer, character, float, arrays. If you use, very difficult to manage. Collection. That data it can hold. Collection can hold. Collection, there is no limit. N number of elements. Accepted, accepted, accepted. Logic already written. I'll show you how it is written. I'll explain. Huge amount of data can be maintained in collection. After getting data in a RAM, you can perform operation. That purpose library methods we use. Those methods are present in collection classes. Those classes are implements these interfaces. These interfaces are the part of java.util package. That is. Okay. Now just you write this one. Set only duplicate will not be there. That's it. In a program, different will be there. I'll show you. Program methods with that different will be there. Is it over? See, for example, you'll write like this. Integer array equal to new integer of 10. How many elements we can store? How many elements? 10 elements we can store. But if you use collections framework, there is no limit. N number of elements add, accepted. But how they return logic? Actually, collections framework also written with arrays only. How they return? Suppose 10 elements you accepted, you stored in this array. When 11th element comes, what they will do is they'll create one more array with 11 elements. With 11 elements, one more array they'll create. These total 10 elements they'll shift here. They'll copy. 11th element also they'll copy. They'll add. Then this array they'll delete. This array they'll rename A. Then it appears like a 11th element added. No? Actually, 11th element is not added to that array. One more array they created. That 10 element they copied in this array. 11th element added. That array deleted. This array renamed. Then it appears like adding 11th element. Okay. 12th element comes. What they'll do? Another array. 12. Then what they'll do? This 11 element they'll copy here. 12th element they'll add. This array they'll delete. This array they'll rename as A. So this logic already written. That's what n number of elements add, accepted. There is no error. Error will not come. Lakhs of elements also you can store in collection. Logic already present. Okay. So like this, not only this logic, so many logics are there. Data structures. To improve logical skills, data structure is the best subject to improve your logical skills. Okay. With the data structures, more logical knowledge comes. More logical knowledge. As compared to these all, more logical knowledge comes with data structures. Now, this is list versus set. List allows duplicate, set does not allow duplicate. Main concept. Next, map. It is a root interface in a two-dimensional collections hierarchy. It is a root interface in a two-dimensional collections hierarchy. It contains data as a key value pair. It contains data as a key value pairs. It does not allow duplicate keys. It allows duplicate values. It does not allow duplicate keys. It allows duplicate values. Note on differences between set and map. 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 Is it over? Oh, no. Here set. Here map. I'll explain just note down. It is a one-dimensional collection interface. It is a two-dimensional collection interface. It contains elements. It contains key value pairs. It does not allow duplicate elements. It does not allow duplicate keys. Values may be duplicated. It is an index based collection. It is a key based collection. I'll explain, just write it. Zero, 1, 2, 3, 4. Index, element, key, value. Note down. Set versus map. Set versus map. Over. I'll explain. Set versus map. Set, differences between set and map. Listen, is it over? See, set. Set, you observe. It is a one-dimensional collection interface. It is one-dimensional collection interface. It is a two-dimensional collection interface. It is one dimensional. It is one more dimension. Okay. It is one dimensional. It is two dimensional. It contains elements. These are called elements. It contains key value pairs. So key value. It is always, it will maintain the pair association value with that key only. Okay. It maintains a key value pair. It does not allow duplicate elements. Here duplicates are not allowed. It does not allow duplicate keys. Here duplicate not allowed, but here duplicate allowed. That's what I written duplicate here. Okay. It is an index based collection. Suppose if you pass 0, you will get a 98. If you pass 1, you will get a 14. But here no index. If you pass key, you will get a value. If you pass this key, you will get a value. Suppose now 1-dimensional, 2-dimensional. Now employee number and salary. Employee number and salary. I want to maintain. Then which record? Map. Employee number is key or value? Employee number, key. Salary? Salary, some people may be same, but employee number will be unique, no? At the time, employee number, key. Employee salary, value. Employee number and name, if you want to maintain. Number, name. Then key which one? Number. Value which one? Name. Like that. Okay. Gmail username and password. Username, key. Password, value. ATM card number, ATM pin number. Card number, key. Pin number, value. Like that. Like that will maintain. Okay. This is theory. Tomorrow programming. Okay. Program very simple. Very simple. As compared to network programming, Java streams, it is very simple. Very simple because everything already written. We'll see continuation tomorrow.